1 minus alpha b WB squared minus 1, you get alpha b is equal to 0.1815. So alpha A, just as a reminder, 0.72. So the pressure drop is going to be larger or smaller for A versus B?
Bigger B.
It's going to be larger in PBRB. That's right. Why do you need it to be larger? The flow is already distributed. The flow is going to be 60-40 no matter what the pressure drop parameter is. That's set by the problem statement. Why do we need a larger pressure drop in PBRB? In order to get the same conversion out of the two reactors. Yeah? Yeah, you already have a longer resonance time, right? Because the flows are unequal, the one with the lower flow rate's going to have a higher conversion, unless you do something about it. So what's a way that we can drop rate without changing resonance time? We can go to a larger pressure drop, because the lower the pressure, the lower the rate. Because pressures are proportional to concentrations, which are proportional to rates. So you didn't have to have that logic in your mind to solve the problem. I never worked out the logic. I just wrote all the equations down and rearranged. But that's what's happening here. Is you need to have a less efficient reactor. So a higher pressure drop just means that the conversion is going to be less, given the same everything else. Same amount of catalyst in this case. This was by far worth more points than the next part, was getting these things. I think the last little statement about how would you do that was only worth 1 point. But it asks, should you use larger catalyst particles in PBR A or B? And it says to assume all other relevant properties don't change. So if I want a larger pressure drop, do I want smaller or larger catalyst particles? Smaller. It's easier to flow gas through Legos than it is to flow it through sand, right? So that's the correct answer. Now some of you said a larger catalyst particle, and you guys were thinking about surface area versus reactivity. In other words, if you said use a larger particle because the ratio of active sites to total catalyst will be lower, and therefore you're going to get a lower rate, you got the point. I mean, it's just 1 point, but you got it. I thought it was a really clever answer. I was happy to see that some of you were thinking sort of outside the box. But the straightforward point was, if I have smaller particles, the pressure drop is going to be larger. The other thing, though, is interesting. The thing to keep in mind, though, and the reason why it didn't occur to me until I saw some of those answers, most catalysts, the vast majority of the surface is not active. You take precious metal, for example, you put it on a support, then you mix it with a binder, then you make it extrude, such that in the end, when I'm talking about catalyst particle diameter, I don't mean the active species. I don't mean the metal nanoparticle diameter. I mean the diameter of the physical particle that you put in your, in other words, of the extrude that you put into your bed. So it's not technically correct, but I liked it, so you got a point. That problem had an average of 25, a median of 25. The medians and the averages were identical. So there weren't any extreme outliers, or I guess I should say the outliers balanced in this test. The mode was 25. The standard deviation was a little bit higher than the others. It was 7.5. For the entire exam, the mean was 68. The median was 67. The mode was also 67, although as many people got a 57 as they did a 67. So there were two modes, really. The standard deviation was 12. The max score was 96. I'm not going to say what the minimum score was. Any questions? Okay, like I said, about the two, yeah. There's two, no. Let me clarify this before we move on. If you want to regrade, you bring me your exam and I regrade the entire exam, except for two parts. in part B, damn it, where the hell is it? In problem 2, part B, you could write down
No, you did it.
I got it. That you would have lost points for, but I'm saying you get those points back. That's what you send me a picture of. The other one was in this last problem, the same thing. Again, you would have lost points, but you get those back. So if you put a 2 here in the last problem and you lost points, send me a picture. You put a 2 here and here and you lost points, send me a picture. Yeah, anything else, those are ones where my rubric was wrong or overly constrictive. Everything else is, I trust the rubric, so if you don't trust the rubric, you don't trust the grader, I get to take a crack at it. Yeah.
Can we show you now when you write our name down? For the 2?
Sure, we've got time. If you guys want to, do that, I'm fine with it.